So welcome all. In this video we are going to learn about the structure of a compiler. Basically what happens is as you have already learned till now that a compiler is used for converting a source language into a target language, one language to another. So what is happening, this all the processes in this compilation can be divided into certain phases. So first few phases can be considered as front end, and last few phases can be considered as back end. Front end is also known as analysis, and back end is also known as synthesis. So what happens actually, these phases, the phases in the front end, they are responsible for reading the source program and understanding the structure and meaning of the programs. Okay, and in backend, these phases are responsible for generating the target language program. Let me repeat this thing. What happens from the for this compilation, we take the source program as input, and we have to generate a target program as output. In between, certain phases are there, and these phases are grouped into front end and back end. So in front end, these phases are responsible for reading the source program and understanding it, and after reading and understanding it, it generates a intermediate representation of the code. Now this intermediate representation of the code can be a tree structure. Generally it will be a tree, you will see, and this will be given as input to the backend synthesis part. So what it will do, it will use this intermediate representation and convert it into the target source program. So very simple this compilation process is. Basically what we are thinking here is the compiler should be able to recognize the programs. Let me repeat, the legal programs, those which are correct programs. Now it must generate a correct code. In the first line we have seen that it should recognize the legal programs, those programs which are written correctly, and after reading this program it will generate a new code in a target language. That generated code should also be correct. Must manage a strong sorry must manage a storage of all variables and data. Okay, must agree with operating system and linker or target formats. Also need some sort of intermediate representation. There are different intermediate representations, as you will see later, but there will be something called a tree representation, you will see. So we will have a different kind of intermediate representation. Still we need some kind of intermediate representation, at least one, which is fixed in one compilation. So front end maps source into intermediate representation. What it says is front end, these phases will map the source program into an intermediate representation, and then this backend will take this intermediate representation and map it to a target machine code. uh, this can be a machine code directly. Machine code means 01. It can be a direct machine code, or it can be a other language also. So here often multiple intermediate representations are possible. uh, Maybe a higher level, or at first lower level in later phases, and so on. So let us see what happens in front end. What are the phases which can be considered in front end? We are saying the front end to be divided into two different phases. One is a scanner and another is parser. The task of this scanner is to convert the character stream into token streams. Okay, so basically we are tokenizing it here, and we create the tokens from the given statement. Then what this parser does, parser tries to understand whether it is written correctly or not, or these kind of things, and generates the intermediate representation. Now these things can be done automatically. uh, Source language is specified by a formal grammar. If there is a language, there is a grammar. If it is a grammar, it can be verified whether it is correct or not. So now the tools read the grammar and generate a scanner and parser, either table driven or hard coded. It is saying that there are automatic tools which can read your grammar and generate the needed scanner or parser for you. Now the tokens. Given the streams of the streams of data, I am saying means a stream, your character streams in the program, we have to recognize the tokens from it. So what are those part of the code which can be considered as tokens? So basically each significant lexical chunk of the program is represented by a token. The operators or punctuation symbols, these all are separate tokens. Keywords like if, while, return, go to, these all keywords will be considered as one token, separate tokens. Your identifiers, ID, maybe the name of the variables, or some kind of things, whatever you write, they will be considered as tokens. The constants that you will keep, uh, they will be considered as tokens, whether it is int, floating point, string, and whatever, all those things. So what a scanner will do, given the statement, it will find out the token, right? So let us assume this is a statement. It says if x is greater than equal to y, then y is equal to 42, semicolon. Now what are the tokens here? So I am telling you this if is a keyword, so if is a token. Left parenthesis is a token. ID x, this identifier x is a token. Greater than equal to is a token. Y is another token. Parenthesis closed, it is another token. Y is a token, however it is being repeated, but it is a token. Is equal to is a token. 42 is a constant, it is also a token. Semicolon is also a token. So basically, what you will understand here is tokens are atomic items. It is not just character strings. Uh, they have some meaning. Comments and white spaces are not always tokens. Some language may define them as token, but usually in most of the language it is not considered as tokens. Now what parser does? There are different forms. We will see. We will go through the parsers. So basically, what is happening is we have to generate some kind of syntax tree. So what we are doing is you will see engineering trade-offs have changed over time. Memory, okay, it is talking about now, since memory is very cheap, so different kind of approaches can be applied and used. Now basically here parser generates an abstract syntax tree for your given program. Essential meaning of the program without the syntactic noise. This is a abstract syntax tree for the given tokens identified in that statement. So these are the what I am telling you, tokens, and for these tokens this abstract tree is constructed. How it is constructed we will see. Such kind of output is of the parser. So basically this will be considered as a intermediate representation which will be used for the next phase. Now static semantic analysis, it is saying that the front end is also responsible for some more things like type checking. Check the language requirements like proper declaration etc. Now whether the resource allocation, preliminary resource allocation as needed. Also it will connect other information needed by back-end analysis and code generation, and then it will give it to the back-end. Now back-end is responsible for translating the intermediate representation into target machine code. Should produce good code. Good means fast, compact, low power consumption. So such code will be good code. Also it should use machine resources effectively. Machine resources means registers, instructions, memory hierarchy, these all sort of things. Back-end instruction. Typically split, okay, it is saying that typically split into two major parts with sub-phases, optimization and code generation. Optimization means we will try to improve the code. Given the code, we will try to understand, okay, where these codes can be improved, and then we will generate the final code. Hmm. Here we will select the instructions to be kept, and we will schedule them. We will allocate the registers and these kind of things. So the input will be a tree representation, abstract syntax tree, which will be converted to a target program, maybe assembly language. So how it started? It started in 1950s, where in 1954 Fortran 1 was introduced, and it was competing with the hand optimized code. Uh, Later on in 1960s, seven different languages like Algol, Lisp, COBOL, and Simula, other languages emerged and started being used. The formal notation of the syntax was especially this BNF, Backus norm. Fundamental implementation techniques were the stack frames, recursive procedures, and such kind of things. In 1970s, this formal methods for producing compiler frontends came out. Many theorems actually came out and were being made automatic. In late 1970s and early 80s, what happened? New languages, functional Smalltalk and object-oriented systems emerged. New architectures came out like RISC machines, parallel machines, memory hierarchy issues. Okay, memory hierarchy issues were there. So accordingly, we need to optimize the compiler also. So after that, we have to give more attention to the backend issues also to generate the code effectively and efficiently. So what happened in 1990s and beyond, like compilation technique appearing in many new places, not only for programming, also for any other software analysis, verification and security. Just-in-time compilers were also introduced. Phased compilation, like where 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 machine learning techniques were also being used for control optimization. So basically, we are blurring the lines between compile time and runtime. Okay. Now, compiler technology. Okay. Critical to effective use of new hardware. We want to improve our compilation technique according to the new hardwares. These are different kind of things, multi-core kind of things are there where we are trying to optimize our system. Now, the course project, what I am telling you is the best way to learn about the compiler is to build a compiler. So we will try to build a small Java compiler as course project. So till the end of this course, you should be able to make this a small project on a small implementation of this Java. It will be a mini Java, subset of Java. So basically what I am telling is few expressions like if, while and these kind of things. If you will be able to include this classes, inheritance and subclasses system, this will be also better. So integer variables and expressions should be there. So these few things, if you will include this, you will include these things progressively, incrementally, I should say. So what you will do is this program, this project should be interesting. Means it should be large enough to be interesting and small enough to be uh, tractable. Means you should be able to complete within this November, right? So it should be small also. So these are sort of things that you will keep in mind. And no language requirement actually, but you can use any language you want, preferably C, C++, Java. These are preferred. So now these are few things that you should do. mm. And groups should be of 2 or 3 and they are programming environment. Okay, no no fixed environment, whatever you will decide you can use. More better eligible to the project. Google Classroom should be gone through, and these are the books. Ullman is the best book you will go through, and you should maintain the academic integrity. Okay, in the next class, in the next video, we will try to include more things. Thank you.